Now let's look into the third component of the Hadoop, that is Yarn. Yarn stands for yet another resource negotiator. Yarn is a resource management platform. Yarn is like a manager of a big team of computers clusters. In a Hadoop ecosystem, it is in charge of making sure the computers and the team work together effectively to process the data task. It separates resource management and job scheduling. In older version of Hadoop, everything was managed using system called MapReduce. Yarn comes in to separate management of computer resources like memory and processing power from specific tasks that needs to be done. That is job scheduling. So it separates the job scheduling and resource management. This separation makes the whole system more flexible and efficient. Beyond just MapReduce, Yarn is not only for scheduling. To run MapReduce, split the task and run MapReduce uh, jobs, but it can also work on with other jobs as well. Efficiently use cluster resources. Think of clusters like a so when we have a computer and we have a certain resources like we have CPU, memory. So we should make sure that when we have multiple processes running within the cluster, we should make sure that each process is getting the required processes, required resources, and no one is starving, and there is a fair resource allocation is happening, and no one is sitting idle, no resources idle as well. So now let's look into the architecture of Yarn. So on high level, so when a client submits a job, when job to the Yarn, so the user will submit the data, map reduce, the information about the data, the map task and reduce task, and so this information will be taken care. So Yarn will have three components, that is the resource manager, which internally has a application manager and scheduler. Then the second component is the node manager, and the third component is application master. Now, so when the client submits a when a client submits a job, so resource manager, scheduler, within the resource manager, the scheduler will be responsible for taking in this job and allocating it with the required container within the node manager. Now the node manager is responsible within the node manager. A container will be created uh, which will have the required resources. This application manager will in turn start an application master within for that particular job within the container within that node manager. And once this master starts within the node manager, the within the worker node, and the application master, which in turn will interact with node manager and request for more resources based on the job or function which we have written. And the application master will again get this application manager will get this request from the application master, and it will interact with resource manager regarding that, and again the resource manager, based with the help of scheduler, will allocate the required resources back to the application master within that data node, within that node, with the help of the node manager. And now this once the process complete, application master will provide this information to the application manager, and application manager will tell the resource manager like this has been completed, and the resource can be released, and the scheduler will in turn pull back the resource and allocate it to a different process. So now, like, let's go through it again. Yarn consists of three main components, that is resource manager, node manager, application master. Resource manager is the master daemon responsible for overall resource management and scheduling of tasks. It has two main components, scheduler and application manager. Scheduler allocates is the component this scheduler is a component that allocates resources to different application based on the requirement. Application manager uh, manages the life cycle of an application running in the cluster. Node manager runs on each machine in the cluster and responsible for managing resources available in that machine. uh, it reports the resource utilization and heartbeat to resource manager. Application master, each application, that is the job we are submitting. For example, I submit one particular map reduce job, so that particular map reduce job will have its own application master created, which is responsible for managing the execution of the task within that application. The application master will negotiate the more resources with the resource manager with the help of application manager. So let's look at the flow again. So resource request, a user will submit the map reduce job to yarn cluster. The job include map reduce application code, input data, desired number of map and reduce task. Resource manager receive the job request and negotiates the resource for it. So basically within the resource manager, the job scheduler uh, will allocate the will receive the job scheduler will be the one that will pull in that particular request and negotiate with the resource manager, and then allocate the required container uh, will allocate the required container, uh, negotiate resource for it, and it allocates container available in a worker node, that is the node worker node. And the then the application manager will be responsible to run an application master within that node. And the application master once starts running, it will based on the input processing that is required based on the function that we have written, it will request for more resources with the application manager which will in turn request with resource manager, and then with the help of job scheduler, it will allocate the required resources. Once that is done, the other task will keep on running, that is the map, phase, shuffle, sort, reduce task. So all these will be managed, will be taken care by the will execution all this execution will be taken managed by the application master. And if it needs any interaction with the uh, resource manager, with the help of and I mean the node manager here will comes into place, managing the resource within its node. Then once the task completes, they report the status to the application master. uh, Status and output to the application master will monitor the resource utility, and it will application master will in turn will tell the application manager that it has completed its job, and it can release its resources. And application manager will let these know to the resource manager, and the scheduler will allocate the resources to another process. So we already looked into what is a scheduler. Scheduler is responsible for allocating the resources to different application based on the requirement, such as fairly among all the application. When user submits a job to the yarn cluster, scheduler is involved in negotiating the resources for the job with the resource manager. Again, application manager uh, monitors the progress of applications and communication within the resource manager. And when all the tasks, it is responsible for managing all the jobs. So for example, whenever it needs more, whenever an application master requests for more resources, it first interacts with the application manager. So initially, when we talk like when an application master requests for more resources, a container is created within a node managed by a node manager. So these container is isolated environment for executing tasks. They encapsulate CPU, memory, and other resources required for the task, ensuring that one task execution does not interfere other task. Few of the notes that we know we should have to know is that resource manager allocate initial resources for application master when it is launched. Our specific resource requirement for application task is not known until then. So again, once application master is started, the application master will check based on the requirement of the function that we have written. It will request for more memory. So yarn is also a master slave architecture where one node is called the master and the other which runs the resource manager, and the other which run which are running in the data node are is runs the name node daemon. Yarn can also resource manager can run in the node where the name node is running. Yarn can run without HDFS, but Yarn requires information about available resources in a cluster to efficiently manage the resources allocation and scheduling. In typical Hadoop cluster, Yarn leverages the information stored in the Hadoop name node to obtain the information about data nodes. This dependency is why Yarn without HDFS is not common, as it might limit the Yarn's ability to allocate resources efficiently. Okay, so this is about Yarn.